In class, we factored polynomials that were quadratics, and we started to factor some higher level polynomials, and this video will give us another example of that process. So if we take a third degree polynomial, so the largest power is x cubed, and we're asked to factor it into linear terms, it's not as obvious as the quadratics that we've had a lot of practice doing. And so what we talked about in class is that we're going to look at all of the factors of our last term. So the factors, those would be what we call p. So p could be plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. And then we look at all of the factors of our leading coefficient, and that could be plus or minus 1 and plus or minus 3. And those would be what we call q. So the possible rational roots for this function are going to be all of the choices that are p over q. So you can see that there are a lot. It could be plus or minus 1 over 1, which is just 1. So I'll just write it as 1. It could be plus or minus 2 over 1, so that would be plus or minus 2. It could be plus or minus 5 over 1, so that would be plus or minus 5. It could be plus or minus 10 over 1. Then it could be plus or minus 1 over 3. It could be plus or minus 2 over 3. It could be plus or minus 5 over 3, or plus or minus 10 over 3. Those are the potential rational roots. Now, how many roots are we looking for? How many linear factors? 3, because this is a third order polynomial. And this is a lot of choices to try doing synthetic division. So on a problem like this, it is helpful to see a graph. You'll notice that on the practice test, I gave you a graph to look at some of the zeros, and likewise on this one. So let's take a look at this graph. This is the graph of f of x is equal to 3x cubed minus 2x squared minus 15x plus 10 that we're talking about. And we can see that there are 3 real roots for this graph. There's a root that's approximately, it's between negative, let's see, so this is 1, and this is negative 1. So each of these are 0.5. So this is somewhere around negative 2.2-ish. This one here is somewhere around positive 2.2, because this is 3 there. And this root here appears to be somewhere between a half and 1, so this could be around 0.6. So let's go back and look at the p's and the q's. And what we remember, we had 1, 2, 5, 10, 1/3, 2/3, 5/3, and 10/3. Well, none of these numbers is approximately 2.2. But that number there, 1/3, no, sorry, not 1/3, the 2/3, that choice could be this 0. That looks like it's around 0.6. So we're going to make our best guess, and we're going to try 2/3. So on a problem like this where you have so many choices for rational roots, you would be given a calculator to take a look at the graph, or you would be given the graph to make your best judgment. This appears to be the only possible root because these are the 3 roots. And none of these numbers are about 2.2 or negative 2.2. So let's try 2/3. So we're going to do synthetic division and test and see if 2/3 is a root. So synthetic division means we're going to do 3 minus 2 minus 15 and 10. And we're going to put x equals 2/3 over here. Bring down your 3. 3 times 2/3 is 2. Negative 2 plus 2 is 0. 0 times 2/3 is 0. Negative 15 plus 0 is negative 15. Negative 15 times 2/3 is negative 10. And so we do get that 2/3 is a root. Now, what this answer means is that when we factor this polynomial, we got one of the factors, so x minus 2/3 is a factor. And it would be multiplied by this quotient in order to make the original polynomial. So these answers give us the next factor to work with. So we're going to start a fresh page here. So we have 3x squared, 3x cubed minus 2x squared minus 15x plus 10, and we just got that that is going to factor to x minus 2/3 times 3x squared minus 15. Now we want to factor to linear terms. That means that every factor should be a binomial that has x to the 1 power. So we have to factor this one down. Well, the first thing anytime you're factoring is you look for a greatest common factor, and we see that 3 goes into both of these terms. So we're going to factor the 3 out first. So we have x minus 2/3, that stays the same, that's 3. And then we'll factor the 3 out of the next term, and we'll be left with x squared minus 5. Now this x squared minus 5, it may not be obvious what that factors to, and so let's try the quadratic formula. If we want to factor x squared minus 5, well, we could say, all right, well, what are the zeros of x squared minus 5? So we would say x is equal to, and this would be setting it equal to 0. So you could solve this two ways. You could add the 5 to both sides. That might be the faster way. And we would get x squared is equal to 5. And then square root both sides and put the plus or minus. So the other roots would be x is equal to plus root 5 and x is equal to minus root 5. So that means that x minus root 5 would be 0 and x plus root 5 would equal 0. So this would factor down to x minus 2/3 times 3, and the factors of x squared minus 5 would be x minus root 5 times x plus root 5. And if we FOILed that all back out, we would get our original polynomial, 3x cubed minus 2x squared minus 15 plus 10. The other way, if you wanted to factor this x squared minus 5 using the quadratic formula, we could also just prove that those roots are correct. So we could do negative b plus or minus the square root of b squared minus 4ac all over 2a. And a is 1, b is 0, and c is 5. So we would say 0 plus or minus the square root of 0 minus 4 times 1 times negative 5 all over 2, which is the square root of 20 over 2, which is 2 square roots of 5 over 2, because the square root of 20 is the same as the square root of 4 times 5, so the square root of 4 is 2. These 2's cancel, and we get, forgot to carry my plus or minus there, so we get x is equal to plus or minus square root of 5. The same that we got just taking the square root of both sides. So that's how you completely factor. If you have a more complicated one where there's lots of potential roots, you want to take a look at the graph and make your best guess as to which of your potential rational roots could be the 0 by looking at the graph.